Or if they get feeling better and they want to come in during period 7 or after school, I've had kids do that, and I don't tell anyone. I'm like, yeah, you have a test tomorrow. I don't like it. Come here, let's work. So if it's something where they get feeling better and they want to drop by school, they can do it. Period 7 or after school. Kiddos there just now joining the recording. I was talking about everyone who's gone today. I hope you check this out because I'm going to try to be as helpful as possible. Praise the Lord. Our test is not today, but it is tomorrow. They just took their forever quiz. And I may as well not say about dropping by today because most of the kids don't watch it until it's too late. We are going to talk about specific details on the test. You ready? Something to write on? Something to write down? How many of you actually look at this list when you study? Okay. We should all be looking at it. Because when I'm giving you hints or problem types, there are specific homework problems, specific notes problems, specific things you can go to look at to be like, oh, we did one. I'm trying to give you hints to be like, hey, we've done one of these. Okay. You have to, hold on, big picture. We have 10 multiple choice, and we have 4 long answers. We have 10 multiple choice and 4 long answer. Remember, on your practice test, there are only 3 multiple choice. That's not very many, and so that's why in Google Classroom is posted the additional extra multiple choice. I don't have, it's not for points, it's not for bonus, it's just for you guys. It would be a very good idea to check out. Right now, I don't have my version worked out, but let's see what we get through today. Maybe we touch on some of them, and then I can post you guys my solutions. I know those help, right? Like for the practice test. My way of working it out. Okay. I'll try to get those posted.
Look at those.
Huh?
Actually, we'll look at those now. When I have time.
What? Because you're somewhat caught up, maybe. Okay, so 10 multiple choice and 4 long answer, and then 1 bonus at the end. And the bonus is a multiple choice. Okay, not impossible. Not impossible. Okay, implicit differentiation. That was skill number. So we talked about those 4 big problems on Friday. If you were gone on Friday. We did 4 big, like, mama questions as far as skills. Yes, shout out Mrs. Ann. But we did, like, 4 big ideas as far as skills. Do you guys remember that the first 2, actually the first 3 were all implicit differentiation, right?
Yeah.
This one, how hard, how tricky was the implicit differentiation? Okay, what in homework made it tricky? X times Y, product rule. I wrote that down. X times Y, product rule, not forget, product rule. It was in homework, it was in notes. How about e to the u? The derivative of e to the u is e to the u times u prime. How about derivative of ln of u? 1 over u times u prime. All things you guys forgot at different places in the homework when we had the derivatives this chapter. Yeah? Okay. Anyway, so implicit differentiation, is the idea bad? No, but are there mistakes that could be made? X times y product. Okay. Let me see what else I have for implicit differentiation. There's a first derivative. There's a second derivative. There's, sorry, I just noticed something. Something to do with trig. Something to do with trig. Make sure you review your trig derivatives. Not just the inverse, which are important for every quiz today, but the old trig, right? How do you take a derivative, don't forget your u prime on all of these. How do you take a derivative of an f to a g? You have to put a log? No. No, f to the g. F to the g. U to the v. Variables to the variables. You have to use a log, bring it down, product rule. Yes, there is one of those. Yes, it is multiple choice. Yes, you have to make it match. And then that's it, as far as multiple choice and implicit differentiation. So what else is in multiple choice? How about 2 different arc trig? 2 different arc trig, one of them with an e and one of them with a square root. Hey, didn't we do a weird square root one on Friday? That's in the extra multiple choice, and I said the simplifying can be funny. Yes, I'm giving you very specific hints. Okay, what else is in multiple choice? Derivative of an inverse. Derivative of an inverse. Derivative of an inverse. P.S. The AP, and hence my test, sadly, in this case, loves to name the inverse random letters, like G is the inverse, H is the inverse, J is the inverse. But if they say that, guys, couldn't you replace that letter with F inverse to make it look like what you're used to?
Yeah.
Okay. So if they decide to name it something else, like a G or an H or whatever, you can always take that letter out and put in what you're used to seeing, if that helps. Yeah.
On the AP, like if it's a long answer, they do something like that, you have to like write it with the letters they give you.
You have to start at the very beginning and say something like let, like they like to use G a lot. Let G equal F inverse, and then you can use it from there on out because you have redefined. Does that make sense?
Remember Mrs. Leon's class, we programmed your calculator, the specific one? I don't know if you remember that, but she used to, you have to put let this equals.
Yes,
I remember.
yes.
Oh,
Or like the alternate definition, I shouldn't say alternate, but the definition of the derivative where I said H and I was like let H equal delta X. Like it's a similar idea. If you want to change it, or last year with e to the 2x minus 3 e to the x plus whatever, and I said let u equal e to the x. Yeah, just redefining. Sorry, derivative and inverse, add a point. And then the only other multiple choice are related rates. There are 2 of them. Technically 3, but one's pretty basic. You guys remember how homework started with basic ones that weren't word problems? They were just short and sweet, that you knew how to do DDT stuff. It's like that. So one of those short and sweet ones, and then 2 more drawn out ones. And the formulas are given for you in both of them.
Nice.
You're welcome.
Like
as far as area or volume or Pythagorean or whatever, the volume or area or surface or whatever formula is given for you. Okay, long answer. Long answer. You have one having to do with implicit / lines.
Lines?
Mm-hmm. What kind of lines do you make in calculus? Tangent, but then didn't we also talk about this spiffy word that could show up that you need to know what it means? Normal means perpendicular. How do you do perpendicular? You just take the derivative and do the opposite reciprocal. Take the M of the tangent line, opposite reciprocal. Okay, sorry, long answer. You have one that has to do with implicit / lines. You have another one that has to do with derivative of an inverse, showing me all the work, all the process. And then the other 2 are related rates. One of them is pretty straightforward, like the multiple choice ones. And then the second one is like I give you the A, the B, the C, the D, the E, like that big old chart that you would fill in. Like we give it the find, the draw, the equation, the derivative, and the plug and jump. So I've given you the outline with a paragraph. Does that make sense? And it is similar to one of your homework problems, not the shadow one. It is similar to one of your homework problems, not the shadow problem. And then the bonus basically has to do with kind of asking you like a true-false sort of thing, and it takes trial and error. I'll just give you that hint. It takes trial and error.
So it's an inverse.
Oh, that requires trial and error too. No, it requires you actually deriving to see if it's true or not.
Okay.
I don't know how to give you any better hint than that.
That's fine.
So there is trial and error on the inverse, right? Like that's a thing. But I meant more like it's a characteristic that isn't something you would memorize. You kind of have to go discover it. Okay. With that, we can be strategic now. And depending on how prepared you are for today, you have ideas to contribute as to how to be strategic. I have up on the, not on the screen, but at least on the computer, I have your test review, all the evens, but I think I posted those answers already online for you, right? Okay, because that way you could go ahead and grade them as you were doing the review. Are there any questions since you've already been able to grade? And if you guys haven't, here you can take a picture. Oh, they don't all fit on one page. If you guys haven't been able to grade, let me zoom out. You can take a picture of the evens, or you can open your Google Classroom. There we go. There are all the evens if you guys need to grade. But are there any test review questions that we need to go over that you don't understand? The next question I'm going to ask is, are there any practice test questions that you guys want to go over? And if there are no positive replies, we'll just go to the extra multiple choice and start playing with practice problems. Kathleen? 115.
I was able to solve it, but I didn't know how to make it.
Okay. I didn't think about pulling out my book, sorry. You weren't able to make it match? Ooh, and it's a derivative of an inverse. Hey guys, isn't that on the test like 2 to 3 times? 1 long answer, 1 multiple choice?
Yeah.
Go team. So number 115, great practice problem for us to peek at. Verify. He has an inverse. Don't worry, I'm not going to ask that on the test. Let's just say yes. Long story short, this passes the horizontal line test. So yes, f inverse of x is a thing. An inverse function is a thing. But couldn't make it match. All right. My snipping tool is currently in rebellion. It's okay. My snipping tool, it's a great tool. I use it all the time. And right now it's being very mad. Okay, let's go over here instead, and let's go to the test review right here, and let's just add a page, and let me pull out the little document camera from Smart. Ay, ay, ay. Sorry, guys. Here we go. Yeah. Oh, goodness gracious. How long is this going to take? I don't know. I tried my snipping tool, but it didn't work. Don't judge. Okay, so, bloop, bloop. You guys, what's the formula for an inverse? You were supposed to know it for today anyway, right? F inverse prime of A, right? -1 is equal to 1 over f prime of B. Okay, so then we have to consider, now remember, they can give it to us in weird ways, but hold on. If the directions were find f inverse prime of A, or if they wanted to, they could have said something dumb like G is the inverse. Find G prime of A. Whatever, it's the same. Okay, who is A, the x of? The inverse or the f? A is the x of f? No. Check it, right? A is the x, f inverse of f? Good. A is, there we go, which means he's what of f? The y value. Yeah. And we're trying to find B, right? Who do we have? F. So who do we plug in? Well, we can plug in B for x as we plug in -1 for y. Good? Now here's where it gets funny. 0, 1, -1, -2. Wait a minute, it doesn't work. Hold on. Does this one need trial and error? No, because can I get B by itself by moving to the other side and cube root? Yeah. So I can subtract the 2, so -3 is equal to B cubed, and I can say that B is equal to the cubed root of -3. Now I don't know the cubed root of -3. I mean, I can pull out a negative because it's an odd powered root, but either way it's like this. Okay. Now wait a minute, don't I still need f prime?
Yeah.
Oh, that's right. I need him for the formula too. So I'm coming back here, I could say, okay, by the way, who is f prime? I need that now. Isn't that just 3x squared?
Yeah.
So I have 1 over 3 times the negative cubed root of 3. Hey, what's a negative squared? Positive, so that makes that a little bit nicer. But then, don't I still kind of have a mess with this guy to the 2/3 power?
Yeah.
So the negative becomes a negative, but then I still have 3 to the 2/3. Now, don't I have a 3 here and a 3 here? What exponent does this guy have naturally? And when I have like bases, because if we're having to make it match.
The 1-1 rule?
Huh?
1-1 rule? In logarithm? And they have the same base?
Yes, except that's like if it's on either side of an equals, we can ignore the base. And this one is just good old-fashioned algebra 1. If they have like bases, I can combine their exponents. But what's the rule? Add. So So I end up with 1 over 3 to the, guys, think of our skills with power rule. Don't we think of 1 as a 3 over 3 sometimes? 3 over 3 plus 2 over 3 is 5 over 3. Or I guess you could write it as 3 to the negative 5 thirds. What did the back of the book have, Kathleen? What are we trying to make it match to?
It had the first one.
The first one, I figured that one's kind of.
Wacky.
And the only reason they were able to do that and not just leave it with the cube root squared or 3 squared cube rooted or 3 to the 2/3 is just because they were like bases. If this was a 2, we would have been stuck. We would have boxed it way back here. But like bases, you can't. Yeah. But the idea of inverse. I don't think I have like a weird cubed root one tomorrow. Okay, anything else from the review that you want to go over? Odds or evens? No? Okay, practice test. If you find something from the review, I still have it open. It's no big deal. Practice test. Has anybody started playing with that? Not that you have to. Remember, it's optional. It's bonus. But it is good. And remember, you do have all of my work posted on Google Classroom for this practice test. So if you guys don't have any questions you want to hear right now, we'll just go to the extra multiple choice. Yeah, C on the back. Okay, this is that snazzy related rates one. That's actually an AP FRQ, so it's probably a little bit more intense in its entirety. But A just says find G. B says find the rate of change. So A is saying find V of 5. But first, I somehow need to get V in terms of H alone first. Because right now it has R and H, so I need to use all of my clues to help me out a little bit. The next one says find dV dt such that H is 5. So I think they kind of want us to get rid of R. That's going to be a thing. And probably the earlier you get rid of R, the easier all of this will be, because you don't want like a dr dt. I'm pretty sure this is HD dt. There must be some sort of clue that lets us ignore R. Oh, John's not here. And then letter C, show that the rate of change of volume. Show that, Kathleen, it's all about translation. So show that the rate of change of the volume, C, dt, is directly proportional to K times, that's a pre-cal scale, the exposed surface area of the water. Isn't the surface area just pi r squared? It's just a circle. So that's what it's trying to get us to do. Directly proportional to the rate of change of the exposed surface area of the water. The weird thing is for A and B it says don't think about radius, and then all of a sudden in part C it says no, now think about radius. The biggest thing in this one is similar. I know it's ironic because it's like cones, but still similar shapes. Because guys, aren't these cones going to fit into the proportionality of the container, like the smaller water levels? Yeah. So if the diameter of the container is equal to the height of the container, guess what's going to be true about the diameter of the water and the height of the water? They're going to be the exact same. So at the very beginning, you could have said H is equal to D, H is equal to 2R, R is equal to H over 2. So at the very beginning, you could have gotten rid of R by plugging in simplifying to get V in terms of H. It would have been a simple plug in 5 at that point. I'd take a derivative and plug in dH dt, and H is 5 at this point. But then down here it says dV dt is equal to K pi R. So you're going to go looking for this. You're going to go looking for this from the dV dt. So Kathleen, I'm assuming you got A and B. What was dV dt that you got in letter B? The formula for it. The formula before you plugged in 5. dV dt equal
1/4 pi H squared times dV dt.
Okay. Now the problem is they're saying we want it related to R, so you're going to have to come back here and then you're going to have to substitute back. So you can still plug in dH dt as a constant. That's -3/10. That's not a big deal. But then h itself, remember that h is, let's see, that'd be negative 3 over 40. What does h equal? 2r. So then 2 squared is 4. 4 over 40 is 10. That'd be negative 3 tenths pi r squared. You've just shown it because you have a constant times the area of the surface. So just by plugging in dH dt, remember h is always changing, but I can come back here, see the relationship between h and r. I can plug in 4h in terms of r, and then I have, look, constant times pi r squared. And constant times pi r squared is that direct proportionality, k times 2, and pi r squared is the area of the surface. Now, nice thing is for the rest of you guys, it was a good question of Kathleen in looking towards the AP and tricky things that can show up in like a longer AP free response question, long answer question. But for tomorrow, this is not going to be important with direct proportionality and going from H's to R's when you've already gone from R's to H's. So good question, Kathleen. I'm just going to get us off this topic as soon as possible. Okay. Anything else that's burning as far as reviews or practice tests? Let's go do some practice multiple choice then. You guys want to run to the back of your homework spiral? Just to get some scratch work? Let's go play with some of those extra multiple choice. But to some extent, you can have some options. We still have about 10 minutes. What do you guys want to see? We have a tricky implicit. Okay, that was a thing. We have an implicit with a trig and a weird U prime. We have an equation of a tangent line with implicit. We have related rates triangle, related rates baseball, related rates circle, and then that's it. Angle ones, number 5. Okay. If you guys want, you can just label it in your homework spiral, extra MC, chapter 2B, extra MC. That's what it is in Google Classroom. It's extra practice. Number 5 is what we're doing. In the right triangle shown at, sorry, it's below, not the right. The angle theta is increasing at a constant rate of 2 radians per hour. At what rate is the side length of x increasing when x equals 4? What should your brain be thinking?
Given in time.
Given in time, right? Break it down. Given in time. So we start off with, we already have the picture. That's good. So if this is like in steps, like a long answer, picture is right there. Cool. The given and the find would be right here. Then we would be looking for an equation that relates. Then we'd be looking for the derivative. And then last but not least, we would plug it and chug it, right? Okay, so given. What do we have?
2 radians per hour.
What equals 2? Right? Who's increasing? Theta. Oh, d box dt, d theta dt. Okay, what do we want to find? Such that? You say such that? Perfect. Picture, we already have it. Equation, you might have to come up with it, but check it. They talk about x, they talk about theta, and they've given us that 5 is constant. What formula puts together an angle with an opposite and a hypotenuse? See it?
Yeah.
So then when I go to derive, couldn't I rewrite this as sine of theta equals 1/5 x? My quotient rule, people, you'll get there. Bottom d top minus top d bottom, derivative of 5 is 0. You'll get there. But rewriting that divided by 5 as a constant makes life way easier. Okay, how do we derive? Okay, so derivative of sine. This is a chain rule though, right? Derivative of the outside was derivative of sine. Keep the times u prime, which is d theta dt, equals, which is the same thing you would eventually get if you did quotient. Now what's the name of the game?
Check.
So, who am I allowed to keep as a variable? This guy, right? He's my unknown. But I need to know plug in 2 radians per second for d theta dt, but wait, why didn't I write cosine? I thought cosine we needed the angle. Don't we need the angle to know the cosine? Because trigonometrically, don't we just need adjacent over hypotenuse? We just need a triangle to know cosine, right? And if they told us that x is equal to 4, then at the instant, I can say, okay, I'm talking about the triangle. 4, 5, this must be 3, right? Now there's movement, but here at this instant, oh, if that's 4, that's 5, that's 3, cool. So who's my cosine that I can plug in? Who?
Oh,
adjacent. Is that okay? So we end up with 6/5 times 5. Dun, 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 6.
Oh.
So can you slow down?
Sorry, 2 times 3 is 6. 6 over 5 is 6/5, and I multiplied 5 on both sides to solve. 2 times 3 is 6. Okay.
Yes, now I am.
We need a cosine. To know cosine, we need a triangle. To know the triangle, we took the 4 clue. We knew the 5 clue. We solved from Pythagorean theorem and got 3, 4, 5, 3. And cosine is adjacent over hypotenuse. And then we just multiplied and moved to the other side, and dx dt is equal to 6. Okay, I might have time to at least peek a little bit. You guys want another related rates one, or do you want one of the skill ones that might be hard to make it match? Implicit? Okay. Let's do. You want 1 or 2? 1? Okay. Number 1. We have to take ddt of the whole thing, right? As is, or ddx. Sorry, not really good. Okay. 2y dy dx, right? Why am I going to come over here? Why am I going to change that to adding a negative? Why am I going to put a box in a triangle? So I have second d first. It's -3. Oh, don't hold that. Plus first d second. Without that, what's the derivative of 7? 0. Without that product rule, everything's going to be wrong. Or it's just not going to work out well. Now I'm moving my -3y, which does not have a dx. I'm moving that, or dy dx. I'm moving that to the other side. I'm moving my 2x that does not have a dy dx to the other side. Getting these two guys on their own, so I can factor out the dy dx, right? 2y minus 3x. At this point, oh, this should be easy. Alright. Oh, and it is. Just kidding. Depending on what direction you move it, would you guys have recognized that this is the exact same thing as 2x minus 3y all over 3x minus 2y? Depending on how you do it, like you could have moved the dy dx's this way, the signs would have all been flipped. So if you ever have an answer that looks like this one happened to just match, I should have moved them to the other side just to trick you guys. But if they ever don't match, I just see it happen time and time again. Remember, if you can multiply top or bottom by a -1, that'd be a negative, that'd be a positive. Good, that'd be a negative, that'd be a positive. Good, you can flip the signs if you need to, or you can factor out a -1. Anyway, that did not apply to this problem. But if you hadn't done the product rule, you would have been looking for it all day. Actually, it probably would have matched. You would have been like, yay, and then do this. I'm going to let you guys go because it's chapel day, right? We have about 30 seconds. Question, what's going to be weird when you go to do this one? What's the derivative of y? What's the derivative of sine of u? Cosine of u times u prime. What you need to be careful of is keeping the inside the same and then keeping your parentheses for the 1 plus dy dx. Would you know how to get dy dx? Alright, you guys want me to show work and post it on Google Classroom? The answer. If you have practice, you can do.
Yeah, awesome.
Yeah, some of you need to make sure your rules are solid and memorize those hardcore because they're not solid yet. Some of you need to study your notes, but some of you just need to practice. Sound good?
Yep.
Yeah, good. Bye, guys. Oh, tomorrow's test day. Sorry, come in early. Yeah?
Yeah.
Yeah? Okay, we can start the test at 10 till. You can come in at 1:45. I'll be running to the meeting, but I'll get here. Sound good? Okay.